Hello students, in this lecture we will discuss some questions of exercise 1.2. First question is, obtain the partial differential equation by eliminating the arbitrary function from the following: y equals to f1 x plus iota y plus f2 x minus iota y. We have to form the partial differential equation from this relation by eliminating the arbitrary functions f1 and f2. For this, firstly, we will differentiate this equation partially with respect to x. When we differentiate it with respect to x, we will get curly phi by curly x equals to f1 dash x plus iota y plus f2 dash x minus iota y. Now, differentiating equation 1 partially with respect to y. When we differentiate it with respect to y, we get curly phi by curly y equals to f1 dash x plus iota y into iota. When we differentiate x plus iota y with respect to y, we will get iota. Next term is f2 dash x minus iota y into minus iota. Now, here we have two arbitrary functions, and with the help of these three equations 1, 2 and 3, we are not able to eliminate f1 and f2. So, we'll differentiate equation 2 partially with respect to x to get curly to phi by curly x square, and this is equal to f1 double dash x plus iota y plus f2 double dash x minus iota y. Now, differentiating equation 3 partially with respect to y. When we differentiate this equation partially with respect to y, we will get curly to phi over curly y square equals to f1 double dash x plus iota y. And when we differentiate x plus iota y with respect to y, we will get iota. One iota is already present there, so we have iota square here, plus f2 double dash x minus iota y into minus iota whole square. We can simplify it as curly to phi over curly y square equals to minus f1 double dash x plus iota y minus f2 double dash x minus iota y, because we know iota square equals to minus 1. Now, when we take minus common from this right hand side, this right hand side becomes equal to right hand side of equation 4. So, by using equation 4, we have curly to phi over curly y square equals to minus curly to phi over curly x square, or we can write it as curly to phi over curly x square plus curly to phi over curly y square equals to. This is the partial differential equation free from arbitrary functions f1 and f2. Next question. Obtain the partial differential equation by eliminating the arbitrary functions from the following. From this relation, we have to eliminate the arbitrary functions f1 and f2. Again, procedure will be same. Firstly, we will differentiate this equation partially with respect to first independent variable x and then with respect to second independent variable t. Here we have two independent variables x and t. When we differentiate this partially with respect to x, we have equation 2, that is curly z by curly x equals to x f1 dash x plus t plus f1 plus f1 x plus t plus f2 dash x plus t. Here we have used product rule. First function as it is, differentiation of second plus differentiation of first, second function as it is, and when we differentiate f2, we will get f2 dash. Now differentiating this with respect to t, we will get x as it is. When we are differentiating it with respect to t, then x will be treated as constant, x as it is, into f1 dash x plus t plus f2 dash x plus t. Now again differentiating it with respect to x partially, we get curly to z by curly x square equals to x as it is. When we differentiate it, we will get f1 double dash x plus t, and then when we differentiate x, we will get 1 into f1 dash x plus t. Now when we differentiate f1 x plus t, we will get f1 dash x plus t, and when we differentiate f2 dash x plus t, we will get f2 double dash x plus t. On adding these two terms, we have curly to z by curly x square equals to this, as given by equation 4. Now differentiating partially equation 3 with respect to t. When we differentiate it with respect to t, we have curly to z over curly t square equals to x is constant as it is, then f1 double dash x plus t plus f2 double dash x plus t. Now differentiating equation 2 partially with respect to t. On equation 2, we have the value of curly z by curly x. When we differentiate it with respect to t, we have x as it is, x will be treated as constant. From this term, we have f1 double dash x plus t. From this, we have f1 dash x plus t, and from this term, we have f2 double dash x plus t. That is this. Now, adding equation 4 and 5. When we add equation 4 and 5, on left hand side we get curly to z over curly x square plus curly to z over curly t square, and on right hand side we have these two terms. जब इन दो terms को add करेंगे, we will get 2x f1 double dash x plus t plus 2 f1 dash x plus t plus 2 f2 double dash x plus t. Now when we take 2 common from this, we have this. Right hand side of equation 6 is same as this expression in the bracket. So substituting the value using 6 here, we get curly to z over curly x square plus curly to z over curly t square equals to 2 into curly to z over curly t curly x. On simplifying, we can write it as this. This is the required partial differential equation free from arbitrary functions f1 and f2. देखो इस केस में हमारे दो आर्बिट्रेरी फंक्शन थे. जब भी हमारे जनरली ये देखने को मिलता है, अगर एक आर्बिट्रेरी फंक्शन है तो जो हमारी पार्शियल डिफरेंशियल इक्वेशन आएगी वो हमारी फर्स्ट ऑर्डर की आएगी. जब दो आर्बिट्रेरी फंक्शन है उस केस में जो हमारी पार्शियल डिफरेंशियल इक्वेशन फॉर्म होगी वो हमारी सेकंड ऑर्डर की होगी. इस केस में हमारे दो आर्बिट्रेरी फंक्शन थे तो जो हमारी जनरली जो इक्वेशन आनी चाहिए वो सेकंड ऑर्डर की आनी चाहिए. तो उसके लिए हम सारे सेकंड ऑर्डर डेरिवेटिव वो कैलकुलेट कर लेंगे. फॉर एग्जांपल हियर वी हैव कैलकुलेटेड कर्ली टू जेड ओवर कर्ली एक्स स्क्वायर, कर्ली टू जेड ओवर कर्ली टी स्क्वायर, कर्ली टू जेड ओवर कर्ली टी कर्ली एक्स. यही तीन हमारे सेकंड ऑर्डर डेरिवेटिव बनते हैं. इनको हमने कंप्यूट कर लिया. फिर हम देखेंगे इनमें हम क्या कैलकुलेशंस करें जिसकी हेल्प से हम आर्बिट्रेरी फंक्शंस को एलिमिनेट कर सकें. नेक्स्ट क्वेश्चन. Obtain the partial differential equation by eliminating the arbitrary functions from the following: Lx plus my plus nz equals to phi x square plus y square plus z square. Let this equation be 1. We call it equation 1. Now differentiating equation 1 partially with respect to x. Here we have one arbitrary function phi. We have to eliminate phi from equation 1. When we differentiate partially with respect to x, we will get L plus n curly z by curly x, because y is independent on x. So when we differentiate partially y with respect to x, we will get 0. And on right side we have phi dash x square plus y square plus z square. And when we differentiate this term with respect to x, we get 2x plus 2z curly z by curly x. Now differentiating equation 1 partially with respect to y. When we differentiate it partially with respect to y, we will get m plus n curly z over curly y equals to phi dash x square plus y square plus z square into 2y plus 2z curly z over curly y. That is, when we differentiate it, we get phi dash x square plus y square plus z square, and when we differentiate this term, we get 2y plus 2z curly z over curly y. We have to eliminate phi, so when we divide equation 2 by 3, uh, phi dash will be cancelled out, so we are left with L plus n curly z over curly x over m plus n of into curly z over curly y on left hand side, and on right hand side we have 2x plus 2z curly z over curly x over 2y plus 2z curly z over curly y. On simplifying it, we can cancel out 2 from here, and we can replace curly z by curly x by p and curly z by curly y by q by using the notation which we have discussed earlier. So it becomes here L plus np over m plus nq, and here we get x plus zp over y plus zq. On cross multiplying it and simplifying it, we get this. This is the required partial differential equation. And this partial differential equation is of first order because here we have p and q. P is curly z by curly x, q is curly z by curly y. Here we have first order partial differential equation, and it was first, and in the question there was only one arbitrary function. So in the solution we have here partial differential equation of first order. Next question. Obtain the partial differential equation by eliminating the arbitrary functions from the following. Here we have two arbitrary functions denoted by small f and capital F. Let this equation be named as equation 1. Differentiating partially with respect to x, we get curly z by curly x equals to minus 1 by x square. For differentiating it, we will use product rule. When we differentiate 1 by x, we get minus 1 by x square into this term as it is, plus 1 by x as it is, and when we differentiate it with respect to x, we get f dash x minus ay plus capital F dash x plus ay. Now differentiating equation 1 partially with respect to y. When we differentiate it partially with respect to y, we get curly z by curly y equals to 1 by x. X will be treated as constant, so there is no change here. And when we differentiate it, we get f dash x minus ay into minus a. When we differentiate x minus ay with respect to y, we will get minus a plus f dash x plus ay into a. Now we have to calculate here double second order derivatives here. When we differentiate curly z by curly x with respect to x, we will get curly to z over curly x square. Again we will use product rule here. When we differentiate minus 1 over x square with respect to x, we will get 2 by x cube into this term as it is minus this term as it is, and when we differentiate this term with respect to x, we will get f dash x minus ay plus f dash x plus ay. Now coming to the second term, when we differentiate 1 by x with respect to x, we will get minus 1 by x square into this term as it is f dash x minus ay plus capital F dash x plus ay plus this term as it is, and when we differentiate this f dash x minus ay plus capital F dash x plus ay with respect to x, we will get f double dash x minus ay plus f double dash x plus ay. This, adding these two terms, we have curly to z over curly x square equals to 2 by x cube f x minus ay plus capital F x plus ay, and this become minus 2 over x square f dash x minus ay plus capital F dash x plus ay plus 1 over x f double dash x minus ay plus f double dash x plus ay. Now we can find out curly to z over curly y square with the help of curly z by curly y. We have curly z by curly y here. When we differentiate this with respect to y, we will get 1 by x as it is into f double dash x minus ay into minus a whole square हो जाएगा plus f double dash x plus ay into a square. So we have curly to z over curly y square equals to a square over x f double dash x minus ay plus f double dash x plus ay. Now we can use this value here in equation 4. Using equation 5 in 4, we have curly to z over curly x square equals to 2 by x cube f x minus ay plus f x plus ay minus 2 over x square f dash x minus ay plus f dash x plus ay plus 1 by a square curly to z over curly y square. Here we have used the equation 5. Now multiplying equation 2 over minus 2 over x. जब हम इक्वेशन 2 को मल्टीप्लाई करेंगे माइनस 2 ओवर एक्स से तो हम देखेंगे कि ये टर्म एग्जैक्टली मैच हो जाएगी. Let us have a look at equation 2. Equation 2 is this. When we multiply this term by minus 2 by x, we get minus 2 over x curly z by curly x plus 2 over x cube into this and minus 2 over x square into this term as it is. You can do it. This is just basic calculation to cancel out arbitrary functions. So when we multiplying equation 2 by this, we have this. Now we can compare equation 6 and 7. These two terms are same in equation 6 and in equation 7. So we can replace these two terms by this value. So we have curly to z over curly x square equals to minus 2 over x curly z by curly x plus 1 over a square curly to z over curly y square. We can simplify it multiplying both sides by a square, and this is the required partial differential equation. If you want to simplify it further, you can combine these two terms like this. When we open this partial derivative, we will get this a square over x square outside. When we differentiate this product with respect to x, first term will be, when we differentiate x square, we have 2x into curly z by curly x into a square by x square, we will get this term. And when we differentiate curly z over x, take जब हम x square को as it is रखेंगे, curly z by curly x को differentiate करेंगे, we have a square into curly to z over curly x square, this term. So we can combine this also, otherwise this is okay. And this is the required partial differential equation free from arbitrary function. Thank you.